My name is Margaret Chenchev. I'm a program manager on the Windows kernel team, and I'm here today with Eric Smith and Matt Wilson. Eric is a dev lead on the Windows kernel team as well. Matt is a dev lead on the Windows Admin Center team. And we also have Paul Bose, who's a dev on the Windows kernel team also, but Paul is going to be virtually with us. So we're here today to discuss with you how to run applications, software in isolation using Windows Sandbox. Before we begin, I just want to mention two things. So first, we've allocated 10 minutes at the end of the session for questions. So if you can please hold your questions to the end, and we'll try to do our best to answer them. And then the second thing is, throughout the session, you're going to hear us using Windows Sandbox, container, guest or guest environment interchangeably. So just be aware, all those things mean the same thing. All right, so in our day-to-day activities, we often go on internet, we download applications, software, different types of software, utilities, tools, and we sometimes run them to perform a task. In some other cases, we run them to experiment or test them. No matter what the use case is, though, at the end, we want to uninstall them and we want them completely gone from the operating system. This is not always the case. So there are at least two problems with what I've just described. So first of all, downloading things from internet and running those applications on the host operating system isn't necessarily safe or secure. And then the second thing is, those tools that I've described, they're not always cleaning nicely after themselves. So if you uninstall them, they leave either state in the registry or files on the file system. And this is not what we really want. So we looked into this, and we realized that internally at Microsoft, we actually had a need. We wanted to have environment which is secure, isolated, and pristine, in which we could experiment with those utilities, those tools. And we wanted to be sure that those things are not going to affect our host operating system. Looking even further into this, we realized that this wasn't just internal need that we had at Microsoft, but was something that all of our Windows customers also needed. So our solution to this was Windows Sandbox. And this is what we're going to discuss throughout the session. There are four important properties in my mind, four things that we would like to mention about Windows Sandbox. The first thing is it's immediately available. What we mean by that is Windows Sandbox is included in Windows Pro and Enterprise. It's included in the Windows Media, ships with the Windows Media. This means that the user doesn't need to go and download anything from internet to make this feature work. They just have to go enable it in the optional Windows features, and off they go. The second important property in my mind is that this environment is pristine. What that means is every time when the user starts Windows Sandbox, they get a clean, pristine version of their host operating system. The registry is clean, the file system is clean. The applications which are installed on the host are not going to be visible in Windows Sandbox. The third property is disposable. No matter what the user does in this environment, no matter what applications which run in this environment change, like registry, file system, all of those effects will be gone as soon as the user closes Windows Sandbox. So none of that persists. The user has an option to manually specify if they want files copied outside from Windows Sandbox, outside on their host. But this is manual operation. This is done on purpose this way with security in mind. Last but not least, Windows Sandbox is secure. We use the Microsoft hypervisor for kernel isolation. We have separate kernel running in Windows Sandbox, such that if the user runs an application which has a kernel exploit, the best that it can do is affect the kernel inside Windows Sandbox, but not the one on the host. So I spent a few minutes describing what Windows Sandbox is, but I actually haven't shown you what it looks like. So this is pretty much what the user gets when they run Sandbox. It looks and feels very much like a traditional VM, but there are quite a few differences, and Eric is going to talk about those differences a little bit later. In this example, I was running the Notepad++ installer because I downloaded some plugin from internet and I wanted to experiment with it. So moving forward, we're going to discuss what features we've already released with Windows Sandbox and eventually what may be coming in the future. So the first thing is we have support for any Win32 app, so we don't do anything intentional to limit what runs in this environment. Any Win32 app should just run fine. The second thing is support, clipboard support I mentioned earlier. The user has the ability to copy and paste in and out of this environment text and files. And this is a manual operation. So the user has to manually specify, I want this, and I want to copy it to my host. The next thing is we have a technology called vGPU, or GPU power virtualization. This is a technology which exposes the GPU to this containerized environment. And this allows us to run applications which are heavy on graphics with really good performance. And we're going to see a demo of this a little bit later. We have a config file, which is pretty much an XML-like file, which the user can specify, the user can alter, and they can change some of the parameters of Windows Sandbox. So the user can say, when I start Windows Sandbox, I want to have network, or I don't want to have network. I want GPU, or I don't want GPU. They can specify which folders from the host should be visible inside Windows Sandbox. They can also specify the read-write access rights and a few other things. We released Windows Sandbox to insiders almost a year ago, and the user feedback that we got was a lot, like overwhelming, but in a good way. So this is the place where I really want to thank all of our users for using the feature, for reporting bugs, for providing us with really valuable feedback. So thank you. What follows is a summary of the most common feature requests that we've received from our users. What our users have said was that sync to desktops, the one from the host and the one from Sandbox, isn't necessary in all cases. And in fact, it might be even confusing to the end user in some cases. So the request was, if we could provide a mode in which the application still runs in isolation, but the user sees only the application window. So you're going to hear us referring to this as RAIL throughout the session, which stands for Remote Application Integrated Locally. The second request that we've received was about the number of instances of Windows Sandbox that can run simultaneously. So currently support only one instance of Windows Sandbox, but our users have expressed interest in having multiple of those running simultaneously because they have use cases which require this. The next request was from our dev users. So they really want to have a programmatic interface which they can use to integrate with Windows Sandbox. They want to be able to start the environment, this containerized environment, stop it, run it headed or headless, do all the things that are possible via the config file, but do those things programmatically. The next request comes from our enterprise users. They're really passionate about managing Windows Sandbox at scale. So they've asked us to provide features with which the enterprise administrator can describe their scenarios, push them down to the workstations, and enforce them. Matt is going to show us a demo of this a little bit later. And the last thing is integration with Smart Screen and Market the Web. The use case here is the user goes on internet, downloads something, and then double-click on it to run it. The operating system detects that that was a file that came from internet, and instead of running it, executing it on the host, it actually spins up one of those containerized environments and runs the file that downloaded inside, this way protecting the host. So with that, I'm going to hand it over to Eric, and he's going to talk about some of the cool technologies which we use behind the scenes, which make Windows Sandbox possible.
Thank you, Marguerite. Welcome, everybody. So as Marguerite mentioned, the idea is to run an application in isolation, and he mentioned we do that securely by leveraging Hyper-V. So in the sense, under the covers, we're really using virtualization technology. And in fact, we use a bunch of technology that the Windows team has been developing for the last several years that form the foundation for several of our container scenarios. And I'm going to call out where a traditional VM isn't really quite suitable for what we want. So the first thing is, if we have a VM, that means we have to boot from something, right? We have a machine. The machine needs an operating system or something. We don't really want another OS to maintain, right? We don't want another OS taking up disk on the file system. We don't want another OS that we have to service. We don't want to, anyways, there's a variety of reasons we don't want an extra image. So instead, we have this technology called dynamic base images, where we essentially take what we can. The user already has a perfectly good version of Windows on their host, right? We'd like to just leverage that inside the container as well. But we can't use the whole thing, right? There's certain aspects that we don't want. Like if they've installed other applications, we don't want that visible inside. Or if they've made changes to certain mutable files, like registry hives or configuration files, that can't be inside the container. So what we do is we construct essentially a directory structure that looks like the Windows directory. For the files that we can share, you can think of it as being a symlink type thing from that new directory back to the host files that we can share. And for things that we can't share, there's a private copy of those mutable files that the container will use. Anytime the host is serviced, this thing gets regenerated and there's a new set of private files. So anytime we start the sandbox, it's going to look like a brand new pristine copy of Windows. That's the same servicing version as what the host has. The next thing that's a little bit different between a traditional VM and what we want to do with containers is kind of on the left-hand side. Normally, we partition a machine. When you're using VMs, you kind of partition. You say, hey, I'm going to take this percentage of memory and just give it to a VM. And it's no longer accessible to the host. And if the host is under memory pressure and that VM isn't using all his memory, well, that's just the way it is. And this makes sense for traditional VM cases because you don't really have insight into what's going on in these workloads anyways. For the sandbox, though, we can do a little bit better. We actually want to treat the payload in the sandbox kind of on equal footing to applications running on the host. So if the application in the sandbox is under memory pressure, you want to be able to dynamically provide more memory and give it to the sandbox. If the host is under pressure, you kind of want to be able to pull it back. So we have that more flexible allocation of memory. The way this works is the guest physical pages that are provided to the VM that is the sandbox, they themselves are virtualized. So we can essentially take a page fault, trap into the host to satisfy it, and then let the container continue. Another optimization that kind of can be achieved based on how that base image was constructed is we can share executable images. So in a normal VM, again, it's very flexible, but you don't necessarily know anything about what's running in the VM. It could be a completely foreign OS. It could be the exact same thing. You just don't know. So in a classic VM, the host might load some image into memory. Let's call it foo.dll. And then the guest might load a similar image. In fact, they might be the exact same contents of the file, but nothing knows that. So one guy loaded something into physical memory. The other guy loads something into his physical memory. They were identical, but no one knew. So we're actually wasting memory in a sense. In the Sandbox case, we know exactly what OS is running inside of there. It's the exact same one that's on the host, which means there's lots of opportunity for sharing. Everything that's already loaded in memory on the host can be given essentially to the Sandbox for free. He doesn't have to load them and allocate memory for those again. The way this is actually done is we kind of simulate like a non-volatile storage and then essentially do an execute in place type thing. So the protocol is updated. Instead of trying to say, hey, give me the contents for foo.dll, you can basically say, hey, I'd like to direct map, that's what we call it, this foo.dll. And if it's a candidate for that, then this protocol basically says, okay, here's the physical address where that binary lives at, and now all we have to do on the Sandbox side is virtually map it in and then execute it directly. That results in several hundred megs of memory savings right there. The next thing that we want to do better on is how we schedule things. Again, with a classic VM scenario, the hypervisor doesn't really have insight into what is running in a VM. We might provide certain knobs where you can say, hey, only give this guy 10% or 20% or whatever of the CPU, or throttle the I/O to some degree. But largely, it doesn't really know anything. It's just kind of round-robin scheduling, the virtual cores across the virtual processor, OSs, VMs. In the case of Sandbox, though, what we really want is if there's a process running inside the container, and he's a high-priority process, and the only thing that would be running on the host is maybe something low priority or the zero-page thread or something like that, well, we want to let the Sandbox have all of the cores, right? And the inverse is also true. If the important things are happening on the host and something less important is happening in the container, then we want the host to have more time, right? And if they're equal, well, then it can be a round-robin type thing. So the scheduler is kind of enlightened in this environment so that certain hints are exposed. So the scheduler has essentially can peer deeper into the host and the Sandbox and know what's important to run and knows the priorities and stuff and can make better scheduling decisions. And continuing with this theme, this is a client-type scenario. We might be running things inside the Sandbox that would like to use the GPU. With classic VM scenarios, you either don't have a GPU and you have to do everything in software, or maybe you do direct device assignment of a full GPU into the VM, or maybe you do some sort of partitioning, but it's usually kind of static partitioning. Hey, this VM gets 20%, this guy gets 20%, things like that. Again, that's not really what we want in this environment. If some game is running in the container and he wants to use 100% of the GPU, he should be able to. So we don't want to give him the whole thing. So really, we want these applications to compete for the GPU, just like any app running on the host. And the way that works, Marguerite alluded to this earlier, this kind of GPU para-virtualization that the graphics team came up with. The GPU is only ever accessed on the host. The way the model works today is applications, let's say it's a DX application, then it talks to the DX runtime, a user mode driver gets mapped into that process's address space, and he can do his thing, and ultimately, he tries to render a screen or whatever, it's ultimately going to call down to the graphics kernel that's going to program the real hardware. And various apps can all be doing this, and they're all competing for the resources. The way this works with the para-virtualization in the Sandbox is, another app can be running in the Sandbox. If he needs to use DX, well, he does exactly what he would normally do. That same user mode driver can be mapped into the container, made visible, so he can load it. and at some point he's trying to render a scene or whatever, and it goes to the graphics kernel inside the container. But from there, he can't program the hardware. There is no hardware. So instead, he now talks to the graphics kernel on the host, and at that point, he just looks kind of like app 1, app 2, and app 3. He just looks like another guy coming down from that top edge and competing for the GPU resources. Anyways, that is kind of a basic glimpse into kind of how things work at a high level. Obviously, we couldn't go into a lot of detail. Now I'll hand it off to Matt. That's kind of showing kind of the future direction of where we're going.
Thank you. So I need you guys' help for a couple minutes here to figure out how fast I get to go through the next couple of slides. Who has heard of Windows Admin Center? Cool. Who has used Windows Admin Center? Even better. All right. So to give a little bit of background, what is Windows Admin Center and why is Windows Admin Center? Basically, my team went and looked at what a day in the life of a standard systems admin managing Windows Server looked like, and it wasn't pretty. There were applications everywhere. Bringing up new people into your company was really difficult because you had a lot of tribal knowledge that you had to bring across. And not only that, but we also had issues with versions. Things didn't run on 2008 that are on 2019. So we kind of sat back and went, you know what, there's a better way to do this. And we came up with Windows Admin Center. This is our single pane of glass that lets you manage all of your Windows servers, and it looks the same regardless of what operating system you're connecting to with it. We can go 2008 R2 with the caveat of there's some things we can't do because it's really old and the APIs aren't there, all the way up to 2019. And not only that, but we're the face of Server 2019 and moving forward, so that all new features, like Windows Sandbox, that are going to be coming potentially to Windows Server, if they are going to be on server and they have a UI component, it's going to be in Windows Admin Center. Now, that brings us to Windows Sandbox. So one of the other cool things about Windows Admin Center is that we can manage Windows clients, Windows 10 specifically. And so Marguerite came to me this summer, and we started talking about Sandbox, and my mind was blown. The possibilities are endless. The things that I can do with this, the environments that I can spin, and the stuff I can do, it's just awesome. But then, because I work on a management platform, I'm like, do you really expect me to walk to every single one of my clients, run these PowerShell scripts, and manually reboot them? I don't even do that on my home network, let alone at work. So we came up with this concept of managing Windows Sandbox from Windows Admin Center. And while I was working on this presentation, it dawned on me that nobody outside of Microsoft or not under NDA has seen this before. So this is really the world premiere of Windows Sandbox in Windows Admin Center. So without further ado, here it is. So at its core, simplicity is what we were shooting for. We wanted to make it really simple to connect to your client, turn on Windows Admin Center, and execute Sandbox. When you connect to a Windows 10 machine and have this tool installed, all you have to do is click on Sandbox and click on Enable. Like Marguerite alluded to earlier, this is in a table view. Oh, this is going too fast. Let's roll that back for just a second. The Sandbox has a table view because at some point in time in the future, we're going to have multiple sandboxes that you can enable and disable. So once I've turned Sandbox on in my environment, I want to do something with it. And now, this is once again where Marguerite started talking about the config file, the XML file. But there's more to it. You have to be able to send over the exe that you want to run. Maybe you want some icons and some scripts to install stuff specifically and uninstall stuff. So we came up with this concept of a package. Before I go too deep into how we're going to do this, what is in this package? Like I mentioned, the installer, the application that you want to run in isolation. You just pop that in there. You got to have an icon file. Well, you don't have to. You can have an icon file, because one of the demos here is I'm actually taking a program and installing it on the host, or on the Sandbox in the host, but I'm also putting a start menu icon on there. So the users, it looks like an application on their machine, but it's running in isolation. I have to have an installation script. This is basically telling Windows what to do with this program. Do I need to pass any parameters? Do I have to do anything special with it? And because we're good corporate citizens, we clean up after ourselves, and we have an uninstall script. And then finally, we get to the configuration files, the WSBs. We support two types, and you can have one or both. You can install things in full desktop mode, which means you're going to have the start bar, or you're going to have the rail mode, which is just scoped in on that application. So let's take a look at actually deploying this now. Right here, I've added a Notepad++ package, and I'm going to upload that to my machine. And that's as fast as it is. Now I have a Sandbox on my machine with Notepad++ installed on it. Right now, we're going to go ahead and head over to that host machine. This is the client that I just installed in, and see what this looks like to a user. As you can see, I've got two new options, two new things that were installed on this machine. Notepad++ Desktop and Notepad++ Rail. If I click on this application, Sandbox is going to fire up, and it's going to automatically launch the application that I described in the package. From here, I can use it just like any other program. I can write, anything in Notepad. I can save it. And then I can go ahead and close the application. But this is where things start getting really interesting. Because here in my documents, I see the file. But if I go to my host machine, that file's not on my documents. Because of the way Sandbox works, it's completely isolated from my host. It has its own file system so that things can exist in Sandbox but not touch my host. Once I go ahead and start closing things, I'm going to get a prompt here. In this mode, we're warned that when Sandbox closes, everything's going to be gone. The next time this application fires up, that file I saved, it's gone. Everything that application that I've packaged has modified in my Sandbox, it's gone. I get a pristine image once again. All right, the next one we're going to take a look at is the rail. Sandbox is going to fire up again. And then as you can see, there's no windows around it. It's just an application. It looks exactly like this was installed on my machine. As with the previous configuration, I can save my files. And I can see that I don't have any files that are coming in from the host machine. That's because everything's isolated. It's nice and clean. All right, now let's take a look at what it takes to clean up after ourselves. When you install packages through Windows Admin Center, we keep a track of what you've installed on that host so that you can come back and see a list of all of your packages and remove the ones that you want. All you have to do is click remove, and then in a second, it's gone. I can even disable Sandbox from Windows Admin Center in the exact same way that I enabled it. All I have to do is reboot the machine, and then we can go back to the host. This is back to my host. And as you can see, Notepad++ is no longer installed in Sandbox mode on my host here. All right, that's enough about managing. Now we're going to have our virtual presenter, Paul, who is going to show you some of the really cool stuff you can do with graphics.
Hey Ignite, my name's Paul Bose. I'm a developer on Windows Sandbox, and today I'm going to be playing a game inside of the Sandbox. And I'm hoping that I'm going to be able to illustrate two things by doing this. Firstly, that windowed mode provides tighter integration for Sandbox applications. So they almost feel like they're part of the host. And secondly, that the windowed mode provides a faster presentation layer for graphics-intensive workloads. So where before vGPU could provide a significantly high frame rate, we didn't have a presentation layer that could actually display that to you as the user. So doing what I'm doing today, playing a video game, wouldn't have been feasible before the combination of these two features. So for expediency, I've gone ahead and opened up a Sandbox in windowed mode already. And you can tell because we've got an icon here, these two directional arrows, and then the word remote. So anything that I launch from inside of this window is going to also be running inside of the Sandbox, which is what I have just done with Steam. So you can see that Steam looks like an application running on the host, even though it's running in the Sandbox, and it also has a tray icon that's designated as running remotely, but otherwise looks pretty much like it's a program running on your computer. So I'm going to be playing the game Cuphead now, and this is a game that I've logged about 45 minutes on so far, just to prepare for this demo, so I'm not very good. So if you want to go to the bathroom, this is the part of the movie you can miss. But But as you can tell, we're already taxing the host GPU. I've got a task manager up here, and you can tell that we're using almost 40 or 50% of the compute resources on our GPU here. Now this game caps the frame rate at 60 FPS. We've actually played other games in the sandbox that were significantly more difficult for GPU purposes and got significantly higher frame rates, but we can't show you those today. So I'm going to be playing level 1 yet again. I have yet to beat it. Alright, so my strategy in this game is to hold down the fire button and jump as much as possible. And that's been working pretty well for me so far. My old strategy was to blame the lag for my mistakes, but the purpose of this demo is to show that we do not lag in the sandbox. It's actually quite performant. So, I don't have my usual crutch. So as you can see, we're using the GPU of the host on the top right of the screen, and things are very smooth, very performant. So any mistakes I'm making are just pure incompetence. My other strategy is to stay just slightly ahead of my problems, which my wife would probably tell you, though that joke might not age very well. Oh no. Oh. Well, as you can tell, I died on purpose to keep this demo short. Luckily for you, I have too little pride to keep reshooting this. So I hope you enjoyed this demo, and we would love to hear your feedback. Thank you.
Just one more thing before we take your questions. Here are 2 links. We have 2 blog posts on Windows Sandbox. The first one is just introduction to Windows Sandbox, and how you can enable it, and what roughly you can do with it. And then the second one is describing what you can do with the config file, and there are some examples as well. And now we can take questions.
For the questions, do please go to the microphone so that we can get your voice on the recording. Right up front.
I saw in the admin center you packaged the file. Is this a native capability of Windows Sandbox that you can send a package to it and it will execute it and persist to the layer? And this was very important. And when you start it, you don't go through execution process again. For example, if you're installing like in a Docker container. So is this a feature which is available that way you can put a layer on top of your Scratch layer?
Yeah, so basically the question was, can we kind of configure the sandbox, I think, so that you don't have to install something in it each time? At the moment, no. So what we can do is you can actually map things in from the host. We have done, one of the things we do as a crutch is using those config files, we might install some software or stage some software on the host, and then in the config file say, here's a setup thing to run. So the images are already there, so it doesn't have to download from the internet or whatever.
But you have to run it on each.
You have to run it on each, exactly. You have to do it on each iteration. So it has to re-register the app or whatever. And you're absolutely correct, that's not ideal. We actually have some things in the works where we might be able to eliminate that, but at this point, it has to be redone. Yeah.
This is actually another request that we've received from our customers, and we call it internally persistence. So as of now, we don't support in I think Eric mentioned, there are quite a lot of challenges, especially around servicing, which we're still figuring out how to work around.
Off to the right.
One thing that we've used Sandbox for up to this point is executing viruses and malware. What would be nice if we had the ability to record or debug inside of a session from outside. So like maybe on the Sandbox window, a button you can push, start recording, launch the malware, stop recording, but not necessarily having to install even on the host, like Visual Studio or anything, just built into the product.
Interesting.
Yeah,
I see. I see.
That's a good request.
Yeah. Okay, thanks for the suggestion.
That's a good idea.
To the left.
Yes. So for Sandbox, we have a use case to use it for package creation or package testing, but some package require a reboot. Then we lost the contents on the reboot. Then, do you have a possibility to say pause or something a snapshot, then reboot, and again, no servicing because it's the same context, same user, same time, something like this.
Yep, that's a great point. That is a shortcoming today, and it's on our roadmap. We are working on that.
Cool. Thank you. And for package creation, have the result of the installation of the software somewhere in order that we can use it for packaging to ship it, right? Because you know the delta difference.
I see, as in install it, capture those side effects, and then redistribute that as a way to, so that's kind of like what we do with server containers and Docker scenarios. That's interesting.
It almost goes back to the same,
packaging thing, yeah.
layering concept, yeah.
Yeah. Okay, we can talk a little bit more after if you want. But yeah.
So, can we? It's too low for me. Can we run the same like custom Windows service in the whatever is already installed on the host inside the Sandbox with the same name?
You mean the same services?
Like, can we install that one inside the Sandbox with the same name?
Yeah, services can run in. So if I understood your question correctly, if we can run the same services that are running on the host, so run the same services inside the Windows Sandbox with the same names.
Install the new versions of the same service, but inside the Sandbox, right?
Yeah. Yeah, that essentially even happens today. There's a lot of services that have to run even to boot the system, and we're running another copy of all those things in the Sandbox.
And it's not only services, but drivers and other things, because like we mentioned earlier, we have a separate kernel in this environment, which is totally independent from the host.
To the right.
Oh yeah, as the previous gentleman spoke about, when I think about Sandbox, I think about detonating things in a bubble. Is there, say you do, we use it to test packages that potentially got downloaded to buy somebody. If you run them in the Sandbox, will you get statistics into like DATP or anything like that, or is everything totally, I mean, is your point it's just basically totally isolated in the Sandbox and can't get anywhere? Or are you able to get the same like information from the machine, even though it's in the Sandbox? So would that get reported back into like a Defender ATP or anything like that?
Yeah, so you're basically saying if you would have had ATP running and noticing certain behaviors or patterns or whatever, on the host it might have caught something, and I think you're asking what happens in the container.
Yeah.
I don't actually, so long term we have,
So even to more to the point, like I think, like the lateral movement, or in ATP, you can see the processes that were spawned off and things like that. Can you get that information out of the Sandbox now?
technically yes, meaning it is kind of just another machine, and anything that's running can still, things in there can observe what's happening and stuff. We would observe it from the inside, right? So if the ATP type stuff was running, it would be running on the inside, but it can capture all the same things. There's actually another.
Would it show up in the ATP portal?
Exactly, that's where I was going to go. So there's another product we have that you guys, some of you may be familiar with, the Windows Defender Application Guard, where you can run Edge inside of a container. It's basically the same underlying technology as Sandbox uses. And they do have the ability to use ATP. So ATP runs inside. The flow is slightly different. Actually, is the flow different? Does it go straight to the internet, or does it go through the host for that?
I'm not too sure. I don't know. But just back to your question.
Yeah, go ahead.
Sorry to interrupt, Eric. Back to your question. Currently, ATP is not supported actually in Windows Sandbox, though there is some plumbing that needs to be done, and this is not done yet, right?
Yeah, it's not there right now, but what I was getting at is we have it for a very similar thing, and it's something we've discussed in the Sandbox space.
Just one more thing that I wanted to mention. So back to your point, some of the things from this containerized environment flow to the host. For example, telemetry, right? So the telemetry flows from Windows Sandbox to the host, and then on the host respects the host settings for privacy and whatnot. So if the host is set not to send that information to outside of this machine, nothing gets out. If the host allows this, then telemetry flows. And then also, we're thinking about some ways for forensic analysis. So people have said, what if one of those, spins up and then does something really, really bad and then disappears? How do we know that this actually happened and where it originated from? We're thinking about, some strategies how to handle things like that too.
Yeah, that was going to be my next point, because if you can launch it via PowerShell and, like you said, you could potentially do something and then be gone and you have no idea what happened.
Yeah, that's right.
The guest, does it have a machine identity in AD, or is it completely unjoined?
It's not domain joined. That's right. Can you domain it? Yeah.
So with the talk about ATP, I assume Windows Defender's not running in the sandbox.
That's correct.
Okay. And my second question would be, a lot of malware will detect whether it's running in the sandbox or not, act differently.
Understood.
Can it tell it's running in the sandbox or not?
Yeah, so so really the question is, is this a good thing to use as a detonation chamber? There's two interesting aspects to that question when we discuss it internally. One is, can we hide the fact that it's in this environment from the software? And then the second one is, who's going to make the decision about whether things were good or bad, so you know if the detonation was harmful or not. We, at least at this point, aren't taking any steps, any unusual steps to try to hide the fact. So it wouldn't be very hard for software to figure out it's running in this environment. There'd be several clues it could use to pick that up. At some point, we might try to do better, but my guess is that'll be quite a ways out before. I mean, I don't even know if it's possible to completely hide that.
I mean, for that usage, would you suggest probably just a normal Hyper-V VM would be better?
Yeah, although even there's probably ways for the software to figure it out. But yes,
Sure. But you could run Defender and everything else.
Sure.
You could run on the.
That's right.
Okay.
That's right.
Thank you.
Yep. You're welcome.
I just wondered if we could actually manage it outside of Server Manager, specifically so that we could land this thing on a Windows 10 machine, simply grab your executable, be interactive quickly to check that payload from the internet. I mean, that's a use case that you guys described that all of us in the room can certainly attest to.
So I think I can take that one. Yes, I can answer a question. No, so Windows Admin Center, it's built on PowerShell, and we actually ship all of our PowerShell scripts. So if you wanted to take them and customize them for your environment, absolutely 100%.
Completely forgotten my question. Completely got it out of my head. Just give me 1 sec.
Sure.
It's okay. Yeah, go ahead.
Sorry. So the isolated machine and the host machine share the same network connection. Would it be possible to have a VPN connection in the isolated machine and to provide a kind of network separation so that the isolated machine only communicates through VPN and the host controls that there is no connection to the attached network?
Do you want to take this one?
Yeah, so I'm not a networking expert, but I'll try to field this. So we do have some knobs, first of all. Like you could turn off, like if you did want to try to use the sandbox as a detonation chamber and you want to make sure he doesn't do something horrible on the network, we can just turn that off via the config file so you don't have a network at all.
Turn it off and on.
Right.
I like to have network, but not to the attached network, but VPN to another network.
Yeah. We actually have Paul, who did this. He's actually done a lot of experiments on his own where he actually sets up a VPN inside the sandbox, but he's doing it deliberately. So he's installing and using that from the inside. Right now, I don't actually remember exactly how the config goes. I mean, we basically have a virtual NIC, but obviously it is routed through the host at some level.
This is the mirroring network, right?
Yeah, I think we turned that one off. Back to the NAT mode, yeah.
Maybe we need to take back the question and confirm with that.
We can maybe talk to you offline and get a little bit more detail.
Yeah, maybe we can exchange contact information. We can talk to our network team too.
That was actually what my question was about networking. So you're saying that you can actually just say have internet access, but don't have access to the rest of my network because I'm doing something that could affect it.
This is the current case.
Yeah,
we
but
can disable the network completely in Windows Sandbox or enable it.
But not, I just want internet access. Because obviously malware isn't necessarily going to run if it can't talk to whatever it's trying to talk to. But you don't want it to go and infect all your other machines that are on your network.
yeah, yeah. You basically want to say he can get out to the outside world, but he can't look at the inside network. So
Is this like
WDAG, yeah. So WDAG, the thing we mentioned earlier, has the ability to do exactly that, but it requires a lot more configuration because we need to kind of know the difference, what's inside and what's outside. That works okay for this WDAG scenario because the normal scenario is an IT administrator setting it up for the enterprise. So they can kind of define that, and it builds on the enterprise data protection stuff. For Sandbox, it's kind of just really a power user feature, and so far anyways, is not an IT admin setting it up. So we don't have a good way to know where to draw the lines. But I think that's a request that's come up. So over time, maybe we can get there too. So.
Just one other quick question. You were talking about you can set this up remotely on machines, right?
Absolutely.
So if you've got an infected machine, what would stop that malware setting it up on all your remote machines and bypassing any antivirus that's on the host?
So I think that, so what you're kind of asking is if I have a management machine, like Windows Admin Center is installed here, there's malware installed on it.
Just using PowerShell, right?
Yeah.
You said it's all done with PowerShell.
It's all done with PowerShell, yeah.
Just execute PowerShell on any of these machines, set up a sandbox, run my malware in the sandbox.
Yes.
It can do whatever it can, connect to all my other hosts. ATP isn't going to stop it, shut it down, it's gone, it's in there.
I know, right? Stop.
You guys shouldn't have said that on mic.
No. At least from a Windows Admin Center standpoint, it boils down to credentials. Credentials and credential management. Unless, because we don't operate necessarily under delegation, like there's no machine trust there. It's actually the credentials of the identity of the user that is executing it. So in order for that to happen through, Windows Admin Center or PowerShell, somebody would have to, have taken your credentials and have access to your network and your machines in order to do that, yes.
But it's a good way to bypass any antivirus, I guess, because otherwise you might get triggered. Even if you've got the credentials, you're going to get triggered if you start running Mimikatz on a machine. Yeah. Okay, that's fine.
I know. Thank you, everyone. Thanks, guys.